Right, so I want to look at 2019, section A, the short questions of the Tech Graphics exam. So this is the higher level exam, and I want to go through, basically the 15 questions. So basically, in the short questions, you have to answer any 10 questions, and there's 15 questions in the exam. The short questions are worth 30% of your overall score. So each short question you answer is worth 3%. Okay, so it's worth the difference in getting that good grade and not. Okay. Now, so looking at question 1. Okay, so generally every year these type of questions come up. Okay. So the first one was fill in the label for each diagram by selecting the given list. Okay, so this one is based on circles this year. So the first one was a circle with a line touching it. Okay, so the line is touching it in one place only. So I know that is a tangent. Okay, so I'm going to just. The next one is a line. Okay, and it's going through the circle. It's not going through the center point. So it's basically taking a section of the circle. Okay, and it's known as a chord. Okay, so that line is known as a chord. Okay, the chords are very important. If you bisect two chords, where the two bisecting lines gives you the center point of a circle. The next one is two lines, okay, and it's passing through the center point. Alright, so it's going to create that grayed out section, and it's known as a sector. Okay, and finally then a quarter of a circle is known as a quadrant. Okay. Okay. Now, so question 2 is our perspective questions. Okay, and these come up every year as well. Okay, so they're guaranteed marks every year if you know what to do them. Basically, what we have is an incomplete perspective view of this shape here, and we need to complete it. Okay, so we have VP1 and VP2. VP stands for vanishing point. Okay, so vanishing point. All right. And also we're going to have a series of lines that are going vertical down. Okay, so look for example, we see this line is just a vertical line, and it's not going to any vanishing point. It's just going straight down. Okay, so let's start completing this. One way of doing it is just if the line's going to the left hand side, you're going to bring it to the vanishing point on the left. Okay, so we're just like that. Okay, and you're going to finish off the rest of these. So get this one here, it's going to come back to this section as well. Alright, so looking at the drawing here, this is very useful. Okay, and I'll just stick this on, and that's going to be a straight line up there. Okay, so that's that one, complete line going back from here to the other vanishing point. Alright, and that's finishing this way. Okay, and then I'm going to have a line coming straight. Okay, so this is all going to be these are all light lines as well, obviously light construction lines. I'm just doing it a little bit heavier so you can see them. Okay, so that's coming up there like that. That's that back section. Okay, this is coming to this vanishing point. Alright, so we're going to see this obviously now as well. They're showing this square box here. Okay, this is there for a reason. So we see to get this other angle here, I'm going to bring a straight line down. This corner here is going to be the corner of the box, and that joins back to the other vanishing point. Okay, so that. Okay, and that's going to get me that section. That's joining up. There, like that. Okay, so I'm just going to draw this in and. Okay. the main thing with these questions is just practicing them, okay? So it's the same principle every year. It just takes practice to know which ones to join. To join where. Okay. Now, so am I finished? I am not. Okay, so I just need to finish off this bottom section down here. So we see there's a line coming out, and that's going to VP2. Okay, so I'll just start in heavy, and I just. Okay, and there we go. Okay, and if you want to just shade it in just to show it the same as this. Okay, and then that's it. That's it completed. Okay, so the prospective questions. Question 2 every single year in the short questions. Okay, so it's very worthwhile. It's a guaranteed question that's going to come up. Question 3 then is usually always an angles question. So the figure shows the outline of a pair of 3D cinema glasses based on 2 regular pentagons. Okay, you're going to have to know your angles here and how to find different angles and so forth. Now, so the first one. Or side dimension A. Okay, so this is A here. It's the diameter of this circle, so we know if the radius is 15, the diameter is twice the radius, so the diameter has to be 30. Okay, so A is 30. B then, okay, so B is the distance between the center of this circle and the left right hand side of this circle. Okay, so what have we got? So we have the overall length of these 2 circles. Okay, I know that this distance here is 15, and I also know this here is 15. I know that this here is 15. Okay, so let's work this out. So 74. So I need to take this, and this distance. So part 1, 2, and 3 away from this. So 15 plus 15 is 30, plus 15 is 45. Okay, so 74 minus 45, and I am going to get 29. Okay, isn't that right? Yeah, 29. Okay, so B is 29. C then, so C is the internal angle on a pentagon. Okay, so we know to find the external angle on any polygon, it's the number of sides divided by 360. So this is 1, 2, 3, 4, 5 sides. So 5 divided by 360, okay, and I get 72 degrees. Now, that 72 degrees is the exterior angle, okay, so this here is 72 degrees. To get part C, I know it's a straight line, so it's going to be 180, okay, minus 72 degrees, and I'm going to get 108 degrees. So C is 108 degrees, okay. That's question 3. Now, so question 4. Let's have a look. Okay, I'll just stick this in here. Now, so question 4 is always a freehand drawn question. Okay, so it's to create a freehand pictorial sketch of the weighing scales and color or shade the sketch in. Okay, so these just take time and practice, but they're a guaranteed question also every year. Okay, I'm after losing my pencil now. Right. Okay, so the important thing with these questions are it's in bold. It's a freehand pictorial sketch. Okay, so don't be using your set squares. Okay, it's a freehand pictorial sketch. Now, so just best way to go with these is just to be able to count the different points, how far in different points are. Okay, so for example, I know that this section here is 1, 2, 3, 4 squares up. Okay, so there's 1, 2, 3, 4. Okay, so that's one, and that comes back. Okay. Okay, now this is just so I'll just want to complete it, okay, because it just takes a little bit of time to do them. And obviously just apply a little bit of shade and sketch. Now don't spend too long trying to apply too much shade or sketch, because you can get in the exam you can get carried away and lost of time. Okay, so make sure you get the overall sketch done, add a little bit of shade, and move on. Okay. Now, so the next one is looking at this was in the graphical puzzle consisting of squares, rectangles, and triangles. Okay, so count the number of squares, rectangles, and triangles. Okay, so this basically just going ahead and drawing the different, or trying to count the different ones. So with the squares, we'll just have a look. Okay, so we have the outer square is 1. With this one here is 2 squares. We have this here. Okay, it's going to be 3 squares, and we have here. Okay, is 4 squares. Okay, so 4 is the total here. Next one, rectangles. So we have a rectangle. We have a big rectangle here, is 1. We have a small one, is 2. We have a big one coming across this way, is 3. Okay, we have a smaller one here, is 4. We have one coming this direction, is 5. We have another one coming this direction, is 6. We have this one here, okay, is 7. And this one here is 8. Okay, so we have a total of 8 rectangles in total. Triangles then, so there's a lot of triangles here. So let's have a look. So so let's take the big ones first. Okay, so we have 1. Okay, we have 2 when we join the diagonals of the square. Okay, so we have 3 here. We have 4. Okay, we have 5, 6, 7, 8, 9, 10. We have 11. We have 12. Do we have more? Okay. Okay, so we got 14 triangles in total. Now, so let's have a look at question 6. Okay, so this is another question that comes up a lot of the time as well. Rotating a figure. So the figure shows below the elevation of a stapler. 3D graphic is also shown. Okay, so here it is here. Rotate A, B, C, D, E. So A, B, C, D, E. Okay, and back to A. About point O, so this is the pivot point, until E reaches the line L1. Okay, so here's E, and we want to rotate until that reaches the line L1. Okay, so O is the pivot point. Okay, so that's the center of rotation. So it's the center of my compass is always going to go on point O. I want to do the point E first because this is my base point. Okay, so I want to find where E reaches the line L1. Okay, so get the distance from E and rotate it to L1. Now that's going to get me, I'll level that one, E1. Okay, so we'll work our way back. The next one I'll look at is point D. Okay, so I'll get point D, and I'll do the same. I'll now rotate this around. Okay, the distance in E and D in the original image, okay, all I'm doing is rotating, so I'm going to get that distance here, bring it up to E, okay, E1, and swing an arc. That's going to get me D1. Okay, I'll do the same thing then with the rest of them. Okay, so for C, I'll take point C and rotate it. I'm going to get the distance from D and C in this view and get it up here, so that's going to get me C1. Alright, so B, same thing, coming around to B with O as the pivot point. Okay, and swing an arc. Okay, I'm going to get the distance from C to D in the original image and now rotate it from this one. Okay, so that gets me B1. And finally then it gets small from A. Okay, I'll just rotate that around. Okay, I'll get B to A in the original view. I'll mark that down here then. Okay, and that's going to get me A1. And then go ahead and just join all them points up. Okay, so E to D. Back to A. Okay, and we should get something like that. Alright, so A 0.0 is my center of symmetry, so I'm swinging around from that point the whole time. Now, so that's questions 1 to 6. Okay, so let's have a look next at maybe question 7. Now, so question 7 is asking us to get the figure. The figure shows the outline, elevation, and plan of a security camera. A 3D graphic is also shown here. So we want to get the true shape of surface S. Okay, so this slanted surface here. So we need to get an auxiliary view. They're telling us to project auxiliary elevation of the camera on the x1, y1 line to show the true shape of surface S. Okay, so this is surface. If this is surface S in my elevation, okay, this line here represents surface S in my plan. Okay, so I need to get an auxiliary view from that. Now, a lot of the time, you'll see that they are 30-degree angles. Okay, so to have them set up, so to get an auxiliary view of that, I'm going to use my 30-60 degree set square. Okay, and I can use, to get an auxiliary view, I'm bringing lines perpendicular to that line. If that's a 30-degree line, a 60-degree angle is going to work for this. Okay, so I want to get a true shape of the surface S. Okay, so I'm going to look this way, so I'm going to pull these lines. Okay, so I want to get a true shape of the surface, so the first point I want to get is the height. Okay, so this is my XY line. I want to get, so I'll actually just extend them lines up as well. Now, so I want to take the heights from, if it's auxiliary elevation, I want to take the heights from my elevation. Okay, so I'm getting the height of this. I get, that's going to be this point here, bring it up, and that's going to get me that point. Okay, I'm going to get this height, down, up, just get me that height. And I'm also going to mark that here. And here. Okay, so that's going to be the true shape of S. Now I want to get a full auxiliary of the shape, or of the camera. Okay, so there's, okay, so that surface there now is a true shape of the surface S. Okay, so it's an auxiliary elevation. Okay, they're worth revising, and they're used in orthographic projection questions as well. Okay, so they're worth looking over. The elevation and plan of a measuring tape are shown in the space provided. Draw a freehand pictorial sketch of the measuring tape. Okay, so this is basically just freehand pictorial sketch of the measuring tape, and you should use kind of the box method to draw it. Okay, so if I was to draw this in, it's going to look like a box shape, so I'm going to draw something similar here. Okay, so alright, so try to get it fairly proportioned. Okay, now again, it's a freehand sketch and you're in exam conditions as well, so it's not going to be perfect, but try to get it as best as you can. Okay, so drawing the bottom on the top. Okay, it's just freehand kind of this circular view there. Alright. Okay, and then we're going to have the front kind of section coming out. Okay. Now, get the okay. Now, if we get something like that in our exam, we'll be doing fairly well. Okay. Now, also you're just going to apply some. Make sure you apply some color and sketch. Okay. So just our color and shade as well. So maybe just shade in this section here. Okay, just to add a little bit of add a little bit of realism into it. Okay, maybe just. Okay. And so on. Okay, so just add a little bit of shade to it as well. Now, so question 9 then. Okay, AutoCAD commands. And if you've done SolidWorks, these might be simple enough. If some people haven't done them, okay, and it can be a little bit tricky if you're not sure what they are. Okay, so this different ones. This one here is going to be, so we want to see the process that's going to get each stage onto the next. Okay, starting from one over to the left. Okay, so what's happening here in this one is basically I have an unfinished line, and the first one I did was I extended it out. Okay, so the first command I did was an extend command. Okay, the next one was I had a line of symmetry here, so basically what I did I mirrored the image across that line. Okay, so the next one is mirror. Next one I did was an offset. Okay, am I missing something? So extend, right, mirror, offset, and finally I did a boss extrude. Okay, to get the extruded surface out. Okay, question 10 shows a design for a glamping pod shown in figure 2 for the incomplete elevation of the glamping pod. Complete elevation by constructing our parabola in the rectangle ABCD. Okay, so rectangle ABCD. Its vertex is at O. Okay, that means the parabola is going to look like this. Okay, so it's going to come around in this shape here, similar to this. Constructing a parabola, we have to divide the lines up, or the sides up, into different sides. Okay, so I'm going to take the line CD. I want to divide that up into a number of parts. Okay, to divide the line up into a number of parts, draw it out from either the angles. Okay, I'm going to divide it into 3 parts. So I'm going to get my compass, mark off 3 individual markings, doesn't matter what size. Okay, 1, 2, and 3. Okay, joining the last one back to the end of the line I want to divide up. Okay, and I'm using my sliding set squares then to create parallel lines to that line. Okay, now if I divide that line up into 3 parts, I want to divide half of the top. Okay, so from the vertex to that line up into the same number of parts. So the line OC I'm also going to divide up into 3 parts. Okay, again, same principle. Get my compass, marking off 3 times. 1, 2, 3. Join the last point back to C. Okay, and using sliding set squares then. Now, Once I have that division up, I can use symmetry to bring the lines over to divide up the other side. Okay, so for example, to divide the line OB up, I'm just going to use my compass, okay, and rotate everything around. So there's one mark, and there's another. Okay, to get these points across, rather than going dividing up that line again, I'm just going to construct them, bring them straight across. Okay. Now, so that gets me that point and that point. Now, when constructing a parabola, the line from my vertex, okay, I need to draw lines parallel to that line from my vertex from this edge. Okay, so these lines here are going to be parallel to that vertex. So I'm bringing the line up, up, and up. All right. From the other points, I'm joining these back to my vertex. So I'm joining these ones back to my vertex. And the same on the far side. Okay, now I'm getting these series of points and I'm going to mark them off. Okay, so this is 1 point, 2, 3, 4. Okay, always starting at the bottom. And working your way in, okay, and then freehand in, draw your parabola. Okay, like that. Again, it doesn't make a difference how much you divide it up into. Probably for short questions, 3 or 4 is enough because you don't want to be running out of time, and it just suffices for them. Development question 11. Show the development of an object. The 3 images of are shown. Which one is it? Okay, so figure A. This figure is A, B, or C. Okay, it can't be A because see the back section of A is missing. Okay, so if it was A, there will be none of this section here. Okay, it can't be C because we see that the top, a kind of tray of this, there's no top on it. Okay, so if it was C, this here will be missing. Okay, the answer is B. Okay, internal tangents. Okay, so the complete outline of the support shown, blah blah blah. Complete the outline of the support by constructing the internal tangent to the given circle. Okay, internal tangents, we add the radius. Okay, so for internal tangents, we're going to add the radius of the 2 circles. Okay, so get the size of the Okay, actually, the first thing we're going to do is we're going to join the 2 centers. Actually, what we'll do, join the 2 centers of the circles. Okay. Join 2 centers of circles, bisect that line, get the semicircle. Okay, so bisect that line. Okay, and get the center of that circle. Now I want the tangent coming up in this direction. Okay, so an internal tangent this way because it has to look the same as this. Okay, so I'm going to get the center and I'm going to draw my semicircle on this side. Alright, now I want internal tangents, we add the radius. So I want to add this radius onto this circle. Okay, so just add that on. And now I want to construct a circle that size. Okay. Where that circle intersects the semicircle that we drew, I'm drawing a line back to my center point. Okay, like this. Now, so this is one point of contact, the point of contact for the tangent on that big circle. Okay, I want to use parallel set squares to get, or parallel lines or sliding set squares to get the same line on the other one. Okay, so I'm bringing it up, getting that. Okay, that's the other point of contact, and then I'm joining them points. Okay, so that's going to give me that line. Okay, and that line is tangential. It's an internal tangent to both of these circles. Okay, question 13 was given the outline of a house. Draw a new outline similar to the given house with the length AB increased to AB1. Okay, so this is scaling up. Scaling up, these questions are the exact same as well, the same principle. Okay, I want to go from AB to AB1. Basically what I'm doing, I am extending from AB out to AB1. Okay. Now, with every other point, I want to extend that line A out through it. Okay, so for example, this top corner, I'm going to draw lines out from A, radiating out through all them points. Okay, now the only thing that changes in these questions are the size, the proportion of the questions, the orientation of the questions don't change. Okay, so in the original image, to get this point, I had a straight line coming up from B. So to get this one, I'm going to bring a straight line up from B, okay, until it hits that line. I had a straight line coming across from there, so that's going to get me that point. Alright, this line was coming down as far as here. Okay. Now we're going to use two parallel lines. Okay, and then that new image there now, so this is all the extended area. So that's how much increasing the size of that house by the size AB. So A is my center, or my center of scale, my point of enlargement, if you like, out through all the points. Okay, from B, then you're just going to use all the different lines parallel to the original lines to get the different points. Okay, and the graphic shows a set of steps. Draw a well proportioned freehand sketch of the plan of the steps. Okay, so just freehand sketch of the plan. Okay, so looking down in this direction. So okay, get this curved section here on. Okay, so maybe just put the square originally and back up. Okay. Now get these curved sections here. Okay, so maybe go and then something like this. Now you're going okay, something like that there. Okay, now finally question 15. Again, these questions aren't going to take you as long because you only have to answer 10. It's taking a little bit longer here because I'm doing all 15 questions. The car sales records were recorded over a period of 6 months. The following are results: January 50, February 50, March, or February 30, March 50, 15. Okay, so we have to draw this. So February is 30, 5, 10, 15, 20, 25, 30. So each one of these is representing 5. Okay, 20, 25, 30, 35, 40, 45, 50. Okay, so March is just 55. So March then was 55, which is this. April was 15, which was this. May was 25, and June was 45. Okay, and draw to finish the graph then. Okay, and that's what we get. Okay, so that's the 2019 short questions completed. Yeah, and again, as I said, I did all 15 questions. You only have to answer 10 in your exam. Okay, each question is worth 5% or 3% of the overall exam, so they're worth putting an emphasis onto.